Hello to everyone watching this video. We hope that you liked our earlier video and it was helpful for all of you. Today we are here to talk about business mathematics. Our stake in today's topic is linear programming problems. Now, linear programming problem can be solved through many ways. First is the graphical method, second is big M method, third is simplex method. Now, as you can see on the screen, we will be discussing on simplex table method. Now under linear programming problems, there is one objective function which either asks for maximizing it or for minimizing it. Let's say I give you an example. If it's profit, then it asks for maximization, and if it's cost, then it asks for minimization. So these objectives are required to be achieved. Optimal solution, which means the optimal solution for the objective function, either it is maximization or it is minimization. Now these optimal solutions are to be achieved subject to some constraints, or we can say the given resources. In this video, we will discuss about maximization problems. Now, some points to be noted before we begin. First, for maximization problem, all constraints should have less than or equal to sign. For example, maximize z is equal to 20x plus 30y, subject to constraints 3x plus 3y less than equal to 36, 5x plus 2y less than equal to 50, 2x plus 6y less than equal to 60, and x comma y greater than equal to 0. X comma y greater than equal to 0 signifies the non-negativity constraint, which means x and y cannot be 0. Sorry, can be 0 but cannot be negative. Now, if not so, such as this case, that means जब less than equal to sign ना हो, such as 5x plus 2y greater than equal to 50. Now, then we have to multiply both sides by -1 to get the less than equal to sign. So after multiplying by -1, we will get minus 5x minus 2y less than equal to minus 50. The third point is the optimality condition. Optimality condition for maximization problem is all values of Cj minus Zj should be 0 or negative. Cj minus Zj will be discussing further. Do not consider minimum ratio if its value comes to be negative value. Now again, you must be wondering what is minimum ratio, which we will discuss in further video. Now there are some steps to solve the problems. First step is to check if the problem is in its standard form, which means the problem contains less than equal to sign. Now introduce slack variables. The third step is to prepare simplex table. Fourth step is to calculate Zj. Fifth step is to calculate Cj minus Zj. The next step is check if optimality condition is satisfied. If after calculating Cj minus Zj, the optimality condition is satisfied, you can stop over there and you know that this is the final table and you can get your answers from the final table. But now, suppose the optimality condition is not satisfied, then we have to move further and prepare simplex table 2 by determining the entering and departing variable. Now, after determining the entering and departing variable, we have to derive the new values for the new table. After deriving the new values for new table, we will proceed as earlier, like calculation of Zj, calculation of Cj minus Zj. Then again we will check for optimality. Now again, if optimality condition is satisfied, then this is the final table and you can derive the values from the table to get the answers. But if the optimality condition is not satisfied, then follow the same process in the same fashion until optimality condition is being satisfied. Once it's satisfied, get the answers from the final table. Moving on, here are some important formulas to be used. First, Zj is equal to summation of value of CBI into corresponding value of basic variable. Now again CBI will be discussed further in this video. Minimum ratio is the solution value divided by the corresponding key column. New value of entering variable is old value divided by key element, and the new value of existing variable is old value minus corresponding key column into corresponding key row divided by key element. These are some important formulas to be used in solving the problems. Now let us begin with one simple question, which is maximize z is equal to 20x plus 30y subject to constraints 3x plus 3y less than equal to 36, 5x plus 2y less than equal to 50, 2x plus 6y less than equal to 60, x comma y greater than equal to 0. These are the non-negativity constraints. Now, beginning with the solution, I, as assumed earlier, as told earlier, that first we have to check whether the question or whether the given objective function or whether the given constraints satisfy the standard form. Now as we can see, all the constraints satisfy the standard form. 3x plus 3y less than equal to 36, 5x plus 2y less than equal to 50, 2x plus 6y less than equal to 60. All the constraints are in standard form, so we don't need to bring them into standard form. Now moving on to the solution, the next step was to introduce slack variables. Now we introduce slack variables into each constraint. 3x plus 3y plus s1 is equal to 36, 5x plus 2y plus s2 is equal to 50, 2x plus 6y plus s3 is equal to 60, and x comma y comma s1 comma s2 comma s3 greater than equal to 0. Now what is a slack variable? The given constraints determine that there is something like 3x plus 3y is either equal to or less than 36. So what we do, we introduce a slack variable, or we can say a small term which makes 3x plus 3y equal to 36 and makes us easier to solve the problems. So after we introduce slack variables in all the constraints, we need to introduce the same in the objective function, which is 20x plus 30y plus 0s1 plus 0s2 plus 0s3. Now as you can see, 0s1 plus 0s2 plus 0s3 do not affect our objective function. Thus we add 0s1, 0s2, 0s3. Moving on to the next step. This is our initial simplex table. We have to create a simplex table like this. Here we will write CBI, we can write CJ here, basic variable, solution and minimum ratio. Now CJ is the coefficient of the objective function, which is 20, 30, 0, 0, 0, which you can check from here. Here you can see 20, 30, 0, 0 and 0. CBI is the coefficient of basic variables which are introduced. We can see the slack variables, the coefficient of slack variables, which is 0, 0, 0. Here we write the basic variables of the objective function x, y, s1, s2, s3. Now here we write the coefficients of the given constraints, which you can see from here: 3x, 3y, 1s1. As you can see, s2 and s3 are not over here, so we'll write 0 and 0. Similarly, 5, 2, s1 is not here, we can write 0. s2 is available, so 1 plus s3 is not here, 0. Similarly, 2, 6, 0, 0, 1. You can see 3, 3, 1, 0, 0, 5, 2, 0, 1, 0, 2, 6, 0, 1, 0. Now we will fill solutions of the given constraints in the solution column, which is 36, 50, 60. Moving on, now as we have filled our column, we need to determine Zj. Now Zj is equal to CBI into value of variable plus CBI into value of variable plus CBI into value of variable, which means the summation of CBI into value of variable. Now we can see here 0 into 3 0 plus 0 into 5 0 plus 0 into 2 0, which equals 0 plus 0 plus 0 equal to 0. Similarly 0 into 3 0, 0 into 2 0, 0 into 6 0, which is equal to 0, 0 into 1 0, 0 into 0 0, 0 into 0 0, which equals 0, 0 into 0 0, 0 into 0 0, 0 into 0 0, which equals 0, 0 into 0 0, 0 into 0 0, 0 into 1 0, which equals 0, 0 into 36 0, 0 into 50 0, 0 into 60 0. Now after determining Zj, we need to determine Cj minus Zj to check the optimality condition. Now Cj minus Zj will be calculated as follows: 20 minus 0, which is equal to 20, 30 minus 0, which is equal to 30, 0 minus 0 equals 0, 0 minus 0 equals 0, 0 minus 0 equals 0. Now as we've calculated Cj minus Zj, the next step was to check for the optimality condition. The optimality condition for all maximization problem is all values of Cj minus Zj should be 0 or negative. Now we can see here we have zeros but we don't have negative, so we can see we haven't reached the optimality condition. So here we need to move further and create new tables. Now for creating new tables, we need to determine the entering variable and the departing variable. So how to determine the entering variable and the departing variable? Since our objective function is to maximize, so we'll see the maximum value of Cj minus Zj, which is 30. So we'll encircle this area, or you can say this column, and name it as key column, the column just above the maximum value, which contains 3, 2 and 6. As you can see, I have encircled it and named it as key column. Now after calculating key column, we need to know which is the key row. So for calculating key row, we need to calculate the minimum ratio, which is here, minimum ratio. Now minimum ratio is equal to the solution variable divided by corresponding key column, which equals 36 divided by 3, 12, 50 divided by 2, 25, 60 divided by 10, 10. 60 divided by 6 equals 10. Now as we can see, the minimum value over here is 10, so we determine this row as the key row. I have encircled it and named it as key row. Now the point of intersection where the key column and the key row intersect is named as the key element. That means the common element in key row as well as in key column, which is 6 over here. These key column, key element and key rows will help us in making the further table. Now, the basic variable or the value of basic variable which is just above the key element is known as the entering variable. You can see I have written over here basic variable above the key element is entering variable, which is y. We denote it as the upwards arrow, and the basic variable adjacent to the key element is known as the departing variable, which is S3 over here. Basic variable adjacent to the key element is the departing variable, denoted as this arrow. Now we will move on to the simplex table 2. You can see over here, this is the simplex table 2, which is of the same format, where you can copy the above two columns from the earlier table. Now, as we saw earlier, y was entering and S3 was exiting or departing. So y will take place of S3 and S3 will go out. As you can see, there is no S3 over here now. We have y in place of S3. Now, again we'll write CBI, which is the coefficient of the basic variables. As you can see, y का 30 था, S1 का 0 था and S2 का भी 0 था. We'll follow the same process, but before following the same process, we need to determine the new values of these columns. The new values of these columns. In order to determine the new values of these columns, we need to know some formulas which I discussed earlier. Like here y, talking about y is the entering variable. So the formula for the values of entering variable was old value divided by key element. So the old values over here in S3 column was 2 and the key element was 6. I hope you have copied the earlier table. If you have not copied, just go back and copy the table, but I have also mentioned the values over here, so if you want you can see from here, but if it is confusing for you, you must copy the earlier table so you can see from there. So we can see the old value under x in S3 was 2 and the key element was 6, which equals 1 by 3. I'm sorry, this is wrong over here, which equals 1 by 3. Another value under y was 6 which is divided by old value 6 divided by key element 6, which equals 1. Key element 0 divided by 6 equals 0. Key element 0 divided by 6 equals 0. Key element 1 old value 1 divided by key element 6 is equal to 1 by 6. Now the solutions comes as the same. Old value was 60, which was divided by 6, which equals 10. Now for S1 and S2, since S1 and S2 are the existing variable which existed earlier in this table, so we have a different formula for the existing variables, which is old value minus corresponding key column into corresponding key row divided by key element, which is, you can see from here, old value is 3 minus corresponding key column, which is 3, into corresponding key row, which is 2, divided by key element, which is 6. So this is the same what we have. Old value 3 minus corresponding key column 3 into corresponding key row 2 divided by key element 6, which equals 2. Similarly, we can again see from the earlier table, old value is 3 minus corresponding key column is 3 into corresponding key row is 6 divided by key element is 6, which equals 0. See over here. Old value minus corresponding key column into corresponding key row divided by 6 equals 0. Okay. Similarly, we will calculate all these values. Old value minus corresponding key column into corresponding key row divided by key element, which equals 0. Again, old value minus corresponding key column into key row divided by key element equals minus 1 by 2, and you can calculate the same for the solution variable also. Now, as 2 will be calculated similarly, you can apply this formula from the earlier table and get your answer, which I have done for you. Now moving on to the next steps. Now again, as we have filled all these value over here, we need to calculate Zj. Zj is equal to value of CBI into value of basic variables and then summing up all of them. Now 30 into 1 by 3 equals 10 plus 0 into 2 0 plus 0 into 13 by 3 0, which equals 10. Similarly, 30 into 1 30 plus 0 equals 30. 30 into 0 0, 0 into 0 0, 0 into 1 0, which equals 0. 30 into 1 by 6 equals to 5. 0 into minus 1 by 2 equals 0. 0 into minus 1 by 3 equals 0, which equals 5 plus 0 equals 5. 30 into 10 is 300. 0 into 6 is 0. 0 into 30 is 0, which equals 300 plus 0 equals to 300. Now, the next step after calculating Zj was Cj minus Zj. Cj minus Zj is equal to 20 minus 10 10, 30 minus 30 0, 0 minus 0 0, 0 minus 0 0, 0 minus 5 is equal to minus 5. Now we'll check the optimality condition. The optimality condition was all Cj minus Zj should be equal to 0 or negative. You can see we have zeros over here, we have even one negative values also, but again we have a positive value over here. So again we haven't reached the optimality condition, we have to move further. So next step for moving further was to determine the key column and key row and the key element for determination of the entering variable and the departing variable. Now we'll determine the key column in the same fashion as done earlier. The basic variable, the maximum value is 10, so we'll determine this column as the key column, and after calculating the minimum ratio, which is done by solution variable into divide key column 1 by 3. So 10 divided by 1 by 3 equals 30. 6 divided by 2 equals 3. And 30 divided by 13 by 3 equals 90 by 13. So we can see over here the minimum value is 3. So we keep this row as the key row. Intersection of the key column and the key row determines the key element, which is 2 over here. Now basic variable above the key element is the entering variable, and basic variable adjacent to the key element is the exiting variable or the departing variable. Now we'll again move further to the next table. This is our third simplex table, which is drawn in the same way: CBI, CJ, basic variable, solution. Now again these two columns can be copied, these two rows and columns can be copied from the earlier table, which 20, 30, 0, 0, 0, x, y, s1, s2, s2. Now as we saw earlier, x was the entering variable and s1 was the departing variable. So x takes place of s1 over here, y was the existing variable, and s2 was also the existing variable, and we can see now s1 has been departed and there is no s1 over here. Again CBI is the coefficient of basic variables. For x it is 20, for y it is 30, and for s2 it is 0. Now we will calculate the values of these variables as we have done earlier. Since x is the entering variable, so we'll apply the formula old value divided by key element. So old value was 2 and key element was 2, which equals 1. Old value was 0 divided by key element, which was 2, equals 0. Old value 1 divided by key element equals 1 by 2. Old value 0 divided by 0 is equal to 0. Old value minus 1 by 2 divided by 2 equals minus 1 by 4. As you can see, we have written over here 1, 0, 1 by 2, 0, and minus 1 by 4. Again the solution variable will be calculated in the same way, which was 6 over here, which will be divided by the key element 2. You can see over here 6 divided by 2 is equal to 3. Again now y and 2 are the existing variables, which will be calculated following this formula: old value minus corresponding key column into corresponding key row divided by key element. You can see the old values, corresponding key column, and the corresponding key row as well as the key element from the earlier table. I have written over here the old value was 1 by 3 minus corresponding key column 1 by 3 into corresponding key row was 2 and the key element was 2, which equals 0. You can see all the calculation and check your calculation from over here and calculate all the values. After calculating all the values of y as well as s2, you can see over here 0, 1, minus 1 by 6, 0, 1 by 4, 9, 0, 0, minus 13 by 6, 1, 3 by 4, 17. The next step was to calculate Zj. Zj is equal to value of CBI into value of variable, value of CBI into value of variable, value of CBI into value of variable, and their summation. Now 20 into 120 plus 30 into 0 0 plus 0 into 0 0 equals 20. 20 into 0 0, 30 into 130, 0 into 0 0, which equals 30. 20 into 1 by 2 is 10. 30 into minus 1 by 6 is minus 5. 0 into minus 13 by 6 is 0. So 10 minus 5 equals 5. 20 into 0 is 0. 30 into 0 is 0. 0 into 1 is 0 equals 0. 20 into minus 1 by 4 is equal to minus 5. 30 into 1 by 4, 0 into 3 by 4 is 0. After calculating this, you will get 5 by 2. Similarly, for the solution variable, 20 into 3 is 60, 30 into 9 is 270, 0 into 17 is 0. Summation is 330. The last step is to calculate Cj minus Zj. 20 minus 20, 0. Okay, it should be 0 over here. 30 minus 30 is 0. 0 minus 5 is minus 5. 0 minus 0 is 0. 0 minus 5 by 2 is minus 5 by 2. Now we can see we have 0, 0, minus 5, 0 and minus 5 by 2. The optimality condition has been reached as we have all the values of Cj minus Zj, 0 and negative. So now we can derive the solutions where the value of Z will be 330 with x is equal to 0, x is equal to 3, y is equal to 9, s2 is equal to 17 with s1 and s3 respectively equal to 0. Thank you for watching this video. We'll be releasing the next part on minimization problem soon, and please like and share this video.